Hello students, and now we are going to continue our second video from where we stop. How do dynamos work? It's a dynamo rely on magnetism and movement to work. If the piece of wire is moved between two magnet poles, as I showed you in a 3D video, that two magnets, north pole and south poles, a kinetic energy of the of wires movement is transferred as electrical energy. If the wire is in a circuit, an electric current is produced. A dynamo has a coil of wires that moves, or the magnets may move. This increases the amount of electric energy transfers. So dynamo rely on magnetism, depends on magnetism means, and movement to work. If the piece of wire is moved between two magnet poles, the kinetic energy of wire's movement is transferred as electrical energy. And if the wire is in a circuit, an electric current is produced. A dynamo has a coil of a wire that moves, or the magnets may move. This increases the amount of electrical energy. Increase the energy. To increase the amount, how you can increase the amount of energy? To increase the amount of electrical energy converted by a dynamo. Many turns of wire are used on a coil, and the coil is turned as fast as possible in a stronger magnetic field. Simply means if you need to increase the energy, that means if you need more light, you need stronger magnetic field. And how you will have a stronger magnetic field, how are you going to convert it? To increase the amount of electric energy converted by a dynamo, many turns of wire, it should have many turns of wire are used on a coil. The coil is turned as fast, that means it should move faster as possible in a stronger magnetic field. Dynamo used to be operate using water power or steam spin the coil. That means either they're going, you can see here here they're using a water power or a steam spin coil. These were able to supply plenty of energy by movement. Victorian light system is a large house were run by this system before a national grid was established. Before the old days, they used this system to generate electricity. Okay, now magnetism. Come to okay students, now dynamos, as I told you, that a device that transfer the energy of the movement of an electricity. So dynamo, what does dynamo do? It transfer the energy of the movement as electricity. Kinetic energy, as I said, energy that moving object have, and moving object have a kinetic energy. What is magnetism? Effect of magnet poles, like north pole and south pole, on a magnetic materials. That means magnetic, like metal or copper wire they will have, when there's to magnetic field, they will have an effect. So this effect is known as magnetism. Electrical energy. Energy of an electric current in a circuit. That means the electric energy of an electric current in a circuit is known as electrical energy. Let's move. Understanding elastic rotational energy. An elastic material have the ability. Elastic materials have the ability to store energy ready for use. The muscle tissue in animal consists of fiber of protein that can expand and contract, providing a potential store of elastic energy. This ability allows us to jump. So because of it says that the muscle tissue in our body, the muscle tissue in animal or even in our body consists of fiber or protein that can expand and contract, providing a potential store of elastic energy. This ability allows us to jump and move and allows the fleas to jump more than 100 times their own weight. Here the flea, you can see that it can fly because of elastic movement. They're able to jump more 100 times their own weight. What is elastic potential energy? What is elastic potential energy? It says energy is stored when an elastic material is stretched or compressed, means squashed, by a force. That means you're stretching something or you're compressing something. The elastic material, it has a stretching force or stretching or compress. So energy is stored when elastic material is stretched or compressed by a force. You do work when you pull an elastic band or squash a spring. This transfer energy which is stored as elastic energy. So when you're stretching something and squashing something, that means you are storing an elastic energy. So pull an elastic band or squash, this transfer energy which is stored as potential energy. The stored energy is transferred when the elastic material returns to its original shape. So the stored energy is transferred. So it transfers when it gets back to its original shape. The further material is stretched or compressed and still be able to return to its original position. The more elastic potential energy can be transferred. That means you're stretching a rubber. When you leave it, it will come back to its original shape. And the further material, as I say, that is stretched or compressed and still be able to return to its original position, the more elastic potential energy can be transferred. Application of elastic potential energy. Catapults and archery bow used elastic materials. Elastic potential energy is stored when the elastic is stretched or the bow is bent. More elastic potential energy is stored if the elastic is harder to stretch because more work is done in pulling it back. And if you see that if you're pulling back a bow, so if it's harder, it needs more work done. So once you are stretching it, the more elastic potential energy is stored if the elastic is harder or stretched. Come to some shock absorbers in a car have strong springs. When a driving over bump, energy is transferred by movement into an elastic potential energy in the spring. The energy is released slowly when the car gets beyond the bump. That means when you see a speed breaker, so when there's a bump, it absorb some of the shocks. The shocks been observed in a car and have strong spring. When the driver over a bump, energy is transferred, means move from by movement into elastic potential energy in a spring. This energy is released slowly when a car gets beyond bump. Elastic potential energy is stored when elastic is stretched or compressed. I'm repeating, elastic energy is what? Energy is stored when elastic is stretched or compressed. Explaining of elastic potential energy. Elastic materials such as rubber are made up of molecules. Elastic materials such as rubbers are made up of molecules that are bound together. That they are made of molecules which are bound together. When the material is stretched, the bond between the molecules store potential energy. So when the material is stretched, the bond between the molecules store potential energy. In its relaxed state, the rubber consists of long strands of molecules which are all collide up. When a rubber is stretched, the coils become elongated and straightened, enabling the rubber to extend in length. When the stretching force is removed, the molecules return to their collide up state and the material return to the original length. The elastic potential energy stored in rubber band or a spring is equal to work done. So the elastic potential energy stored in rubber and band or spring is equal to work done, because how much you're stretching it, that means there's a work done going. So it's equal to the energy stored in rubber or a spring. So what's work done? Energy transferred by a force moving a load equal to the force applied. The distance through which the load moves, or the force you're using it moves the direction. And its elastic potential energy is stored when elastic is stretched or compressed. Okay, that's for this chapter, students. We'll move to our next. Knowing the difference between heat and energy. Let's heat and energy. Let's go to this one. The hottest temperature ever recorded on the earth was 76.8 Celsius in Death Valley, USA in 1913. So the hottest temperature ever recorded on the earth was 56.8 Celsius in Death Valley, USA in 1913, and the coldest was -89 Celsius in Vostok, Antarctica in 1983. What do we actually mean by how hot or how cold something is? Temperature. We use scale of temperature to measure how hot or how cold something is. So temperature is what? To see how hot or how cold something is. So we use the scale of temperature to measure how hot or how cold something is. The common unit is degrees Celsius. The instrument we use to measure temperature is known as thermometer. The instrument used to measure temperature is called a thermometer. So we use the scale of temperature to measure what? We use temperature to measure what? How cold or how hot or how cold something is. The common unit is degrees Celsius. The instrument we use to measure the temperature is called a thermometer. Standard thermometer measure the temperature from 0, temperature at the which water freezes, and to 100 degrees Celsius, which temperature of water boils. Also on 0 the water will freeze, and when it reaches to 100 the water will boils. Okay. So Temperature is what? How hotness of an object measured. That means how cold or how hot is. Heat is what? If its heat is the form of energy is transferred as a flow of heat from a hot object to a cold. So it's a it's a transfer of flow of heat to an hot to cold object. The energy transfer as, that means a transfer of energy is known as a heat from hot to cold. So is if there is difference between temperature between two objects in a contact between two and objects and its surrounding, there is a transfer of energy as a flow of heat. Heat always flow from hotter object to colder. So heat always move from what? Heat always flows from the hotter object to a colder object. Heat will continue to flow in this direction until the two objects reach the same temperature. For example, if you have two glass of water, one's cold and one's hot, when you're pouring hot water in a cold water, it will keep until the temperature will become same. The heat will continue to flow in this direction until two objects reach the same temperature. So heat will continue to flow in this direction until two objects reach the same temperature. The greater difference in temperature, the faster flow of heat. So greater the difference, so the faster the flow of heat. Greater the the greater the difference in temperature, the faster the flow of heat. We use this principle of heat transfer to the heat and cool objects or our surrounding. If you put some food at room temperature. Now what's room temperature? The temperature of your room is known as a room temperature, a constant temperature. Temperature is 20 degrees. In the fridge, fridge is at 5 degrees Celsius. So it's the temperature of your room. So your room temperature, the temperature of your room is known as a room temperature. Energy from the warmer food will transfer to the colder surrounding of the fridge. So that means when you put something in the fridge, so it was at a room temperature, so slowly it will start moving, because heat always flows from the hotter object to the colder object. Transfer to the colder surrounding of the fridge. This will reduce the temperature of the food and cool it down. Let me show you how actually it works. See how it goes. Heat and temperature. Come on. And come back to this. Come on. Let it upload. Let it download a bit, so I'll explain. I'll come back to that. So here, heat and temperature. Think about a cup of water at 80 degrees Celsius, the big bucket of a warmer water at 30 degrees Celsius. You know that the water in a cup has the higher temperature, but which holds more heat energy compared to here. Say that a cube of centimeter of a water particle in a bucket has 40 joules of energy, and the cubic centimeters of water particles in a cup has 250 joules. Which would hold the most energy overall, the cup or the bucket? The temperature is measured, the measure of the energy of the individual particle, how fast every moving object, they are moving about. Heat is the total energy of all particles, measure of not only how fast particles are moving but also the total number and type of particle. Each cube centimeter of water particle has, say, 40 joules, and each cubic centimeter of the water particle has 250 joules. So they have more joules, that more energy comparing to this one. I need you to I need you to find out which will have more bucket or cup glass. So what is temperature? I need you to find out. I have explained this thing to you. So how heat move from hotter to colder. So I need you to find out which one will have more cup or bucket. Temperature as a hotness of an object measured usually in degrees. Degrees Celsius is what? A unit of temperature. And heat is what? A form of energy is transferred as a flow of heat from a hot object to a cold object. Let's come back. Here you can see the state of matters. We have liquid. These are the particles in solid. You can see this is how the particles in solid are. Part in liquid and gas. You can see in solid, liquid, and gas. Phase transitions, melting point. So you can see here solid will melt to liquid and liquid will freeze to solid. And here sublimations, melting point, sublimation, boiling and evaporation, condensation from here, boiling and evaporation, and from gas to liquid is condensation, deposition from gas to solid, and sublimation from solid to gas. And the process you can see here, this is a process of solid. Liquid, you can see melting and heat transfer. So you can see how the heat's been transferred to gas, boiling, evaporation, heat is transferred, you can see here, and solid, deposition and heat reduction. This is how the heat's been transferred. Let's move to our next, thinking about fuels. A dried animal dung has served as a fuel for humans all over the world since prehistoric time. Today, over 2 billion people still use this as their main source of fuel. So, animal dung has been used as a fuel for humans for years. Dung from cow, buffaloes, and camels is commonly heated and burned. So, dung from cows, buffaloes, camels is commonly heated and burned. The energy is used for cooking food. They use it as a heat. They use it for what? For cooking food, heating, and drying. Common fuels. What are the common fuels? Are a chemical that transfer energy to the surrounding. Fuels are chemicals that transfer energy to the surroundings by heat when they are burned. So what's fuel? Fuels are chemicals that transfer energy to the surrounding around you by heat when they are burned, when you burn them. They have chemical potential energy. Now what is chemical potential energy? Energy stored in a bond between atoms which becomes available when atoms are rearranged in a chemical reaction. So they have a chemical potential energy. Many different type of fuel exist and they may be solid, liquid or gas. So for chemical potential energy, energy stored in a bond between two atoms which becomes available when atoms are rearranged in a chemical reaction. The most commonly used fuel are coal, crude oil, and methane, a natural gas. Car engine used liquid fuel such as a petrol and diesel or gas called propane. So car used liquid fuel such as a petrol, diesel or a gas called propane. An aeroplane use heavier liquid called kerosene, and a racing car use a lighter liquid fuel such as nitromethane. All of these are processed from crude oil, the natural oil that they get it from the earth. They have advantage of burning quickly and easily transferring energy rapidly. So the advantage of is that they are burning quickly and easily and transferring energy rapidly. Wood and wax are solid fuel. So what are the solid fuels? Wood and wax are solid fuel that provides heat and light. These burn much more slowly than liquid fuels. So they burn slowly comparing to your liquid fuel. So you have here coal is a solid making electricity or coal fire. Natural gas used, what is state? Gas making electricity or cookers. Petrol is a liquid state fuel for vehicles. Diesel liquid in an engine of a car, boat and train. Liquids, these are the states: liquid, solid, liquid or gas. Kerosene liquid fuel for planes. Methanol and nitromethane liquid fuels for racing cars. Wood is a solid, fire and boilers. Combustion: when fuels are burnt, they combine chemically with oxygen from the air. The process, combustion means burning, that means fuel are burned. Reaction of fuels with oxygen that produce heat is known as combustion. That means the reaction of fuel when it's burned with oxygen, it produces heat. When fuel are burned, they combine chemically with oxygen from the air. The process releases heat energy. It is called combustion. Heat source, for example, a match or a spark in an engine start the process of. A chemical energy is transferred to the surrounding by heat and also by light and small amount of sound. A problem with the fuel. Fuel derived from a crude oil belong to a family of chemical known as hydrocarbon. That means you get fuel or you get from a crude oil and they belong to which family of chemicals known as hydrocarbons. Now what is hydrocarbon? Compound such as many fuels containing only carbon and hydrogen. That means fuel which is mostly made of what? Made of carbon and hydrogen. The formula is here: a hydrocarbon plus oxygen will give you carbon dioxide plus water. When they burn, the following chemical reaction takes place. So when they are burned, what will happen? The following chemical reaction take place, transferring energy by heat and light to surrounding. So hydrocarbon plus oxygen will give you carbon dioxide plus water. Carbon dioxide is a greenhouse gas and so contribute to a global warming. Because of carbon dioxide, what's happening? It's contributing a global warming. Burning carbohydrate also produce acidic rain. This damages forests, plant, living things in lake. So because carbon dioxide, it's affecting it's a global warming. It's affecting what? Forests, plants, and living things in lakes. we have used so much crude oil that the earth's supply of oil is running low. That means we have used too much of crude oil from the earth, so the supply of oil is running low. That means by time we will reach, we will have no more crude oil to make fuels. So crude oil is a fossil oil, means it takes millions of years to form. So crude oil is a fossil oil, means it takes millions of years to form. That means once it's finished, it needs millions of years to regenerate or to form again. So chemical potential energy, energy stored in a bond between atoms, which becomes available when atoms are rearranged in a chemical reaction. Then oxygen, a gas produced by plants, use it for breathing and in combustion. Combustion is what? A reaction of fuel with oxygen that produce heat. So reaction of combustion is a reaction of fuels with oxygen that produce heat. Hydrocarbon compounds such as many fuels contain only carbon and hydrogen. And what's compound? All of you are familiar with it. Compound, two or more elements are chemically joined together. Okay students, that's for this video and we'll continue in next video.